Okay, let's dive right into this. Welcome to today's explainer on system design. So today we're unpacking one of the absolutely most fascinating architectural shifts in modern software engineering, and that is the evolution of microservices. Look, if you follow system architecture at all, you already know that how we structure our backend literally dictates how successfully an application can scale, adapt, and honestly just survive in production. We're going to take a really deep dive into the source material to map out exactly how architectures fundamentally transform, growing from these single, massive, heavy blocks of code into super agile, highly distributed ecosystems. It's kind of like watching a giant puzzle rearrange itself.
Now, the concepts we're tackling today center around a huge milestone in the source material, which is referred to as Day 17. But hey, this is way more than just a number on a calendar. Think of Day 17 as this major conceptual pivot point in the life cycle of any software system. It represents that exact make-or-break moment when an architecture reaches critical mass. It's when you have to stop just writing functional code and actually step up into the realm of true architectural strategy. Because at this stage, that old monolithic approach, it's starting to buckle under its own weight, and it's basically screaming for a structural overhaul just to survive at scale.
So here's our roadmap for today. First, welcome to Day 17. Then, understanding the monolith. Next, the microservices evolution, followed by defining service boundaries. Then we'll hit discovery and API gateways. And finally, practice, converting the system.
All right, Section 1. Welcome to Day 17.
Moving right along, Section 2, Understanding the Monolith.
To really wrap our heads around the evolution of system design, we've got to take a deliberate look at the baseline first. Picture something massive, heavy, and just deeply, deeply rooted. That is your monolith, the traditional unified system design architecture. Let's say we're building a massive e-commerce platform. In a pure monolithic design, the whole shebang, the UI, the product catalog, the shopping cart logic, the payment processing, it is all tightly woven together and packaged into one single executable unit. It is completely unified. But as you can probably guess, that unity comes with a brutally heavy operational cost. I mean, if you want to tweak just one tiny feature, or worse, if your payment processing crashes, the entire giant block goes down with it. You literally have to redeploy the whole heavy application from scratch just to push a minor update. It's exhausting.
And that brings us to this really fascinating transitional phase, the modular monolith. Okay, so it's still a single unified block, but now it has internal organizational divisions. Going back to our e-commerce example, this is where developers logically separate out, say, the shopping cart code from the payment code using distinct folders or namespaces. It forces the engineering team to actually start thinking about separation of concerns, right? Getting those clean internal interfaces set up. But here's the catch. While the code might look super neat and organized on your screen, under the hood, it's ultimately still compiled and deployed as one giant unit. It gives you the illusion of separation. Still, it acts as a really vital stepping stone before you take on the absolute immense network complexity of a truly distributed system.
Which brings us to Section 3, the microservices evolution.
Because eventually, that single modular block just becomes way too restrictive. We have to completely shatter it to unlock real agility. Just look at the direct contrast here between the monolith and microservices. On one side, you've got this giant, unified structure acting like a heavy iron anchor. And on the other, you've got the agile, independent pieces of microservices buzzing around like a fleet of nimble little speedboats. So, if our e-commerce platform gets hammered with a huge Black Friday traffic spike specifically hitting the checkout, microservices let you dynamically spin up more of those speedboats just for the services getting crushed with traffic. You scale exactly what you need rather than being forced to clone that entire massive monolithic anchor over and over.
So, this is our ultimate architectural destination, microservices. By definition, these are independent, fragmented services that collectively make up a system. But to really appreciate this, we have to look at the sheer depth of their independence. I mean, each service is essentially its own mini application. Back to our platform, your payment service could be written in Go using a super robust PostgreSQL database for strict transactional integrity. Meanwhile, your product catalog service, that might be written in Python pulling from MongoDB for incredibly fast read access. They do not share code, they absolutely do not share databases, they're technologically agnostic and completely isolated from one another. Yet they communicate over a network to seamlessly create the illusion of a single, unified system for the user. It's pretty brilliant when you think about it.
All right, let's jump to Section 4, defining service boundaries. So if shattering the monolith is the end goal here, how do we know exactly where to make the cuts? You can't just take a hammer to the system and hope for the best, right?
You've got to establish clear service boundaries. These are the exact dividing lines that separate your different microservices, and this leans heavily into the concepts of domain-driven design. You don't draw these boundaries based on some arbitrary technical divisions. You draw them around strict business capabilities. I mean, the domain of processing a credit card is fundamentally different from the domain of managing warehouse shipping logistics. Those logical real-world business divisions, they become your hard architectural boundaries in the code, ensuring every single service handles one distinct capability perfectly.
Moving on to Section 5, Discovery and API Gateways.
Now, once you've carved up the system along those domain lines, you actually introduce a brand new massive problem. How in the world do these separate services communicate with each other? In our old Monolithic app, if the cart needed to check inventory, it was just a simple instantaneous internal function call right there in the memory space. Easy. But now the cart and the inventory are completely independent fragments floating out there in the cloud. That simple internal call is suddenly a network request. It has to traverse servers, which introduces potential latency, timeouts, completely random network failures. Finding the right service instance dynamically becomes absolutely critical.
And the technical solution to that problem is service discovery. This is the mechanism that allows independent microservices to find each other in what can be a pretty chaotic cloud environment. Think of it kind of like a highly dynamic address book, but obviously with a lot more technical depth. As our microservices scale up and down based on traffic, they are continuously sending heartbeats, basically automated health checks to the discovery server. This makes sure the system maintains a real-time, self-updating registry. If an inventory service node randomly goes down, it misses its heartbeat, and service discovery instantly stops routing internal traffic to it. It's totally crucial for keeping the whole ecosystem resilient.
But wait, what happens when the outside world tries to connect? Well, that requires an API gateway, which is defined as the central entry point managing communication for the microservices. Look, if a user opens your mobile app, their phone shouldn't be forced to look up and memorize the IP addresses of 50 different backend microservices. That would be insane. The API gateway acts as that single front door, but it does way more than just route traffic around. It handles all those vital cross-cutting concerns right at the edge of your network. We're talking managing user authentication, enforcing strict rate limits to stop DDoS attacks in their tracks, handling SSL termination. It does all of this before the external traffic ever even touches your fragile internal microservices.
And finally, Section 6, Practice, Converting the System.
All right, we've covered a ton of architectural theory, and now it's time for the action-oriented phase of converting a system, tying this whole narrative together. Step 1. Analyze that heavy anchor you currently have. Really understand the monolith's data flow. Step 2. Establish your service boundaries using that domain-driven design we talked about, making sure your cuts actually map to real business capabilities. Step 3. Integrate the crucial infrastructure. You've got to set up service discovery to act as your internal glue and implement the API gateway as your secure front door. And finally, step 4, achieve microservices. You launch that fleet of independent speedboats, resulting in a highly scalable, totally fault-tolerant, and super agile distributed architecture.
As we close out our analysis of the source material today, I want to leave you with a bit of a provocative question, something to really challenge your day-to-day engineering work. Are you building a monolith right now without even realizing it? Seriously, take a look at your current repositories. Are components that should be totally independent actually tightly coupled together? Are your domain boundaries getting blurred by shared databases? Take a hard, honest look at your own architecture. Identifying those hidden monoliths might just be the exact spark you need to kick off your very own microservices evolution. Thanks for joining this explainer, and we'll catch you next time.